Okay, this is MathLinks 8, Chapter 10. This is Section 10.2 and 10.3 combined. These are two-step algebraic equations. Two-step in that it has both a coefficient and a constant. And if you look at 10.2, this is a 10.2 equation. It's actually probably a grade 7 version because there's no negative coefficients or negative values on the other side. So these two questions were really from a grade 7 perspective. And it says solve each equation by drawing a diagram of a balanced scale in blocks. Well, we use algebra tiles instead of blocks, but 6n plus 6. If we draw our balanced scale, our n is going to be represented by one of these algebra sticks or algebra tiles. And that represents an integer. We don't know what number it is. It could be a positive number, it could be a negative number, but it represents a number. And there's 6 of them. So there's 1, 2, 6 of them. Plus, there's 6 more. So we're going to put 6 integer chips up here. So this side, 6n plus 6, is represented by this drawing. Okay? There's 6 n's represented by the algebra tiles and a plus 6 constant. We call this the constant. It's our value that we know. And on the other side, we have 12. So when we look at that scale, both sides are equal, and that's why we use a scale. So the principle of algebra is whatever you do to one side of an algebraic equation, if you do the same thing to the other side, it maintains this idea of balance or equality. So on the first side, what I want to do is I want to get rid of this plus 6 or this constant. When we have two-step equations, you always want to get rid of your constant first. And we do so in terms of the drawing by putting 6 negatives down. If I want to get rid of a positive 6, I want to subtract 6. And what that would look like algebraically, if I did it with numbers, I would do that. But whatever I do to one side, since I put 6 negatives on this side, I have to put 6 negatives on that side. This creates 0 pairs all around here. These create 0 pairs here. And if I redraw what I have, I now have 6n left over here equals 6. Okay, so I have 6n equals 6. Oh, that's not what I want to do. So then what I want to do, if 6n has the weight of 6, then if I was to divide those 6 n's onto individual scales and put 1 n on each of those sides, then I would have to take this side and divide those equally. And each of these mini scales would then tell me that an n has a value of 1. N has a value of 1. And I could check to see if that solution is correct by going back into my original equation, which was 6n plus 6 equals 12, and substitute that n value of 1 into my equation. So instead of saying 6 times n, I'm going to say 6 times 1 plus 6. And if both sides are equal, then that's the solution. Simplify it. And I have 12 equals 12. So n is 1 in that solution. In the second example, the difference here with the second example is a couple things that are a little bit unique. The first thing is your variable is usually on the left-hand side, but in this particular question, it's on the right. It's right over here. As well, usually your constant is your second part like it was over here, but in this second question, question B, it's your first part. And we'll see that it doesn't make a difference, especially when we draw it. So if I draw this, I have 13 equals 9 plus 2p. So the only difference with this one is they're both balanced. Now they're both equal. Throw on the scale. They're both equal. So the first thing I'm going to do is get rid of my constant by applying a negative 9 to both sides. Negative 9 goes to both sides. This creates all 0 pairs. And this creates all 0 pairs except for those 4. So in my new picture, I have 2p left over here because all of this has created a 0 pair. Really what I did is I subtracted 9 from both sides. And over here, I have 4 left. Okay? So then the same thing in the last question. If I have 2p equals 4, then each p must represent a weight of 2. Or therefore, p equals positive 2. Okay? If I go back into my original equation, which is up here, and I substitute p for 2, then 13 equals 9 plus 4, 13 equals 13, that's true. So the value of P must be 2. In the second example, it says a model with algebra tiles. This is the exact same type of question with the first one. It's a little bit different because of B. So we're going to look at these two just real quick just to show you what it looks like. In the first example, A, we have two G's, or two variable tiles, and a positive 4, represented by 4 positive integer chips, equals -6. So in the two-step algebraic equation, I want to get rid of my constant first. In order to do so, I'm going to apply a -4 to this side. In order to keep it balanced, I want to put a -4 on the other side. I'm left with 2G's equals -10. And if 2G's equals -10, then each G must have a weight of -5, or G equals -5. Double check my answer through substitution. 2 times G is the same thing now as 2 times -5. 2 times -5 is -10, and -10 plus 4 is -6. So the solution is correct. G is -5. In the second example, we have -2r minus 7 equals -11. So to represent a negative variable, -2r. So instead of using, if this was shaded in, that would be representing an r. But what we're going to do here is we're going to leave it open like we do with the positive and negative integer chips. This is going to represent -2r, just like this represents -7. So the equation -2r minus 7 equals -11 looks like this. All of our parts of our equation are negative. The first thing I'm going to do is I'm going to add positive 7 to both sides to get rid of the constant. And when I add 7 to both sides, we create a whole bunch of 0 pairs. And what I'm left with is -2x, or -2r in this case, equals -4. And the same thing happens here. If I actually make this into a -x equals -2 and a -x equals -2, my solution becomes -x equals -2. And this is where it gets confusing when we use a modeling perspective, because that's not the solution. If a -x equals a -2, then therefore a positive x must be a positive 2. And the only way we can really show that is by thinking about opposite operation. If I asked you, what is the coefficient in x? Most people might think that 0 is the coefficient. But in actual fact, it's 1, because a coefficient defines how many of the variable you have. So in 1x is the same thing as x. So negative x over here is actually a -1 coefficient. Okay? A negative x can be thought of as being a -1 coefficient. And therefore, when I look at this solution, because my solution is -x equals -2, if I really wanted to isolate the variable to get a positive x, I would divide both sides by -1 to get rid of that -1 coefficient. Give me x equals a positive 2, because a negative divided by a negative is a positive. So from a modeling perspective, it's a little confusing when you get down to the solution, because it says a -x equals a -2, and you must understand that therefore a positive x must be a positive 2. Okay? But don't worry about it, because on your test I won't quiz you on modeling negative coefficients, but I will quiz you on solving it using opposite operation. In question, the third one, show you know, it's solved by applying opposite operation. So this time we're going to just follow our steps for isolating variables. And when you have 2 steps, the first thing you should get rid of is your constant. And if I look at this equation, my constant is right there. Actually, not that plus sign, just 4. Right? My constant is 4, which means to apply opposite operation, I'm going to subtract 4 from both sides to get rid of that 4. When I do so, I'm left with 26g equals -52. Now some people say, do I need this positive sign? Well, not really, because that's not actually the sign of it. That's just the operation. But you can assume that it's still a positive 26 if you want to keep that plus sign there. So it's positive 26. To isolate the variable, when you have just a coefficient, you divide by the coefficient. You end up with g equals -2. And that's your solution. If you want to check your answer, go back up here and substitute negative 2, where g was. So instead of saying 26 times g, I'm going to say 26 times negative 2. This is going to be 4 plus negative 52, which does work out to be negative 48. So that is the correct solution. Question B. It says negative 3x plus 7 equals negative 19. Now remember, if we were modeling it, it would be negative 3x plus 7, something like that, equals 19. But we're not modeling it, but you just have to keep that in mind. That's what it would look like. The first thing I want to get rid of is my constant by subtracting 7 from both sides. I get negative 3x equals the sum of 19 positives and 7 negatives, or 19 take away 7, which is 12. I'm then going to get rid of my coefficient. This is where it gets confusing. In grade 7, if you had 2x equals 8, you would divide both sides by a positive 2, which is the same coefficient. So this time in grade 8, you're going to divide both sides by negative 3 to get x equals negative 4 as your solution. Go back and check your answer by substituting. So instead of saying negative 3 times x, I can say negative 3 times 4 plus 7 should equal 19. Negative 3 times negative 4 is 12. 12 plus 7 is 19, so therefore the solution is x equals negative 4. I think that's the end of your show your notes, is that right? Okay. So keep working at what you're doing. If you have any questions, slap that like button. And if you have any questions, yes.